Are you also tired of bug-ridden Python code? Do you sometimes want to destroy your computer because of this? Then we have the solution for you! Mypy! I can hear you thinking, what is Mypy? Mypy is a type checker for Python. Normally, Python is dynamically typed. This means that the developer does not include typing in his code. Having no types can result in various kinds of bugs. Mypy forces the programmer to include typing. While you might think this would give you overhead, forced typing has proven to fix up to 15% of the bugs up front. So how can you use this nifty tool? By installing Mypy and running it in your IDE or via the command prompt, Mypy can be used. The program will tell you if there are any typing mismatches in your code, accompanied by the line numbers of the erroneous code. Similarly, if there are no errors, this is also visible in the command line. Now let's dive a bit deeper into the code aspects of Mypy itself. What is the architecture, and is it created in a nice fashion?
The global architecture is quite simple. Since the main functionality of Mypy is type checking, we discovered the architecture to represent a pipeline. A pipeline architecture means that the process is going through multiple filter elements until it gives some information back to you. The architectural properties can clearly be seen in a simplified runtime diagram. From the call to main.py from the command line, Mypy will start type checking. The main will then call build.py. Build.py is responsible for creating all helper classes. For instance, the different kind of error outputs that can be displayed to you. After that, build.py creates a build manager, which uses all information given by the helper classes. The build manager, on its turn, calls the semantic analyzer, which checks all dependencies in your Python program. Using the dependency information, the build manager finally calls the type checker. The type checker checks your program. Lastly, the type checker returns any typing errors to the build manager and the build, which returns it to main. Then you will get any typing mismatches in your command line. Nice, right?
We would like to give you some insights into how Mypy is developed and how we contributed to it. Mypy aims to maintain its quality and functionality through continuous integration. There are three things it strives to do to maintain the quality of the type checker. The first is to identify open issues and solve them. Secondly, to refactor and simplify code. And lastly, it provides an extended test suite to check functionality. The extended test suite is built up of 4 different layers. First of all, there is a unit test layer, which tests each component individually. Secondly, integration tests ensure that the individual components work together as intended. Thirdly, regression tests ensure that everything keeps working correctly as new content or functionality is added. And lastly, Mypy checks for code quality standards using Flake8. While diving deeper into the code, we also reviewed if the quality standards are upheld and whether code analysis tools could come up with refactoring suggestions. Using 2 code analysis tools, namely SonarQube and Sigrid, we found that Mypy can be refactored in several ways. The main takeaway from the analysis by SonarQube were the code smells. Of these, SonarQube recognizes 4 different categories in ascending degree of severity, with the number of issues found per category. These are as follows: blocker code smells with no issues, critical code smells with 462 issues, major code smells with 202 issues, and minor code smells with 136 issues. Similar to SonarQube, a review of Mypy is done using Sigrid. Sigrid had pretty much the same suggestions in terms of refactoring based on code smells. What distinguished the analysis of Sigrid over SonarQube were its suggestions on maintainability violations, which is obviously because secret requires componentization prior to its analysis. For a more in-depth discussion of these topics, you can read our third blog post. In terms of code contributions, our group was able to make 3 pull requests. What we noticed was how challenging it can be to get even minor functionality merged with the master branch. To give you an idea of what kind of issues we worked on, one issue we tried to solve was on disallowing the unpacking of strings in tuples.
Now that we've covered the code quality of Mypy and our contributions to it, we'll explain why Mypy as a type checker is important for more than just the software developer in his Python development team. Because Mypy is just a type checker, you might think that it can do just that, type checking. However, the Mypy tool can be useful for multiple roles in a development team. For example, a product manager might want to adjust Mypy to give them information about the amount of code type checked via reports. Testers might want to test only parts of the code, whereas developers might want to have extra freedom while writing the code. To these purposes, Mypy has included various options in how it can selectively type check code and how it shows information about this code. This makes it a valuable asset for the whole software development team. Now, with all this information about quality, configurability, and the architecture, we tried to contribute to Mypy. All our contributions and even more information about Mypy can be found on our webpage.